when solving for things that we've done earlier, we have certain properties that we have to follow. The first one is called the addition principle. What the addition principle tells us is this. If A equals B, if that's true, then if I add a number to A and the same number to B, they're going to be equal. What does that tell us? Whatever you add to one side, you add to the other side. That's what it tells us. Have we done it already? Yes. 3x plus 2 equals 5. How do we solve for x? First thing you have to do is get rid of the 2. How do you get rid of the 2? Yeah, you have to, whatever I do to this side, I do to that side. That's the addition principle. That's the addition principle. We've done it already. The next one is the multiplication principle. What that one says, if A equals B, then if I multiply something to A and I multiply the same to B, it's the same answer. It's the golden rule. Whatever you do to one side, do to the other side. But we just have different names for them. Why do we need to know this? It's how we solve for equations. We need to know these to be able to solve these things. Three-fourths x minus 1 equals 7/5. We've talked about how to solve these. These are fractions, right? So what do you do when you're trying to solve for fractions? Get rid of them. So yeah, the first thing you have to do is what? Find the LCD. The LCD is what in this case? We have two denominators, 4 and 5. What's the smallest number that they both fit into? Yeah. If you don't even think about it, just multiply them together. So the LCD is 20. What do you do with the LCD? Multiply it. So 20 times the first one. So this is a term, this is a term, that's a term. So multiply the LCD to each term. What's my third step? Reduce. So can anything cancel in the first one? Yeah. How many times does 4 go to 20? 5. There's nothing here. How many times does 5 go to 20? So that's what we have now. After we get rid of our fractions. Again, I ask you again, the first equation or the third equation, which one's easier to deal with? It's a no-brainer. It's the third one. Get rid of the fractions. So my next step is multiply to get rid of the parentheses. 5 times 3 is 15. 20 times 1 is 20. 4 times 7 is 28. And then solve. using the addition principle. Remember, always get rid of addition and subtraction first. So what do we get rid of? We have to get rid of the 20. So we have to add 20 to both sides. $15x equals 48. Then what? Yes, this is multiplied. Do the opposite. 15 divided by 15 both sides. So x is equal to 48 over 15. Can we reduce that any further? Remember, if you can reduce an answer and you don't, you'll get it wrong. Well, how do we know that they both have something in common? What is 15 multiplied by? 3 times 5, right? Does 5 go into 48? How do we know? Yeah, the only way it's divisible by 5 if it ends in a 0 or a 5. But is it divisible by 3? How do we know that? If we take the numbers of 48, 4 plus 8, that equals 12. Is that number divisible by 3? Yes. So 48 is divisible by 3. 3 times 16. So the 3's cancel. 5 goes into 16. This, you can leave it the answer like this, even though it's not right. How many times does 5 go into 16? With how many left over? And there's what the answer should be. Never leave an answer is an improper fraction. But the computer will take it because it's easy to program. Your answer should be this, but it will take that. Pretty straightforward. It's always the same steps. Let's look at the next one. Two times 5 minus 3x equals 8 minus 3x plus 2. Mm-hmm. Order of operations. Are there any fractions? No. So we don't have to worry about that part. So since there's no fractions, what's our first step? Can we do anything inside the parentheses? No. So we get rid of the parentheses. If you can't do anything inside there, get rid of them. How do you get rid of them? Distributive property. So 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6. 8 equals 8. Negative times positive is negative. 3 times x is 3x. Negative times positive is negative. 3 times 2 is 6. Remember, treat your signs and your numbers separately. You'll decrease the chances of mistakes. Now what do? Rule of thumb, anytime you get rid of parentheses, always combine like terms first. Can we do anything on this side? Can we do anything on this side? Yes. So we have 10 minus 6x here. The 8 and the negative 6. How can we combine those? What property says we can use those? We talked about them yesterday. The associative property. First off, I can commute them. I can move them around. I can move the negative 6 right here. But the associative property says I can do these two first. So 8 minus 6 is 2 minus 3x. So I take care of these two first. All right. When you have x's on both sides, always move the smaller x to the larger x. Now, some of you all would say move the 2 and the 10 first. No. What are you solving for? X. So that's the important thing. Move the x's first. So move the smaller x to the larger x. Get all the x's on one side. Which one's smaller? -6. -6 and -3. Because if you do it this way, your x coefficient will always be positive. If you move the 3 over here, it'll be a negative. So I'm going to move the 6x to the other side. Always move the x's first. And some of your high school teachers may have told you the x's always have to be on the left side. No. It doesn't have to be anywhere because x equals 2 is the same thing as 2 equals x. It doesn't have to be anywhere. It's just that that's the way they memorized it. They learned it. So that's the only way it can be. No, it could be anywhere. Don't listen to your high school teachers ever again. So here we have 6 minus 3. Since 6 is bigger, notice we have a positive coefficient in front of the x. All the x's on one side. So that means everything else has to go to the other side. So we have to get rid of the 2. We subtract 2 from both sides. 10 minus 2 is 8. If you want to, at this stage, if you really, really, really have to have x on the left-hand side, switch them. But let me tell you, in mathematics, it doesn't have to be on any side. It just has to be there. Last step, divide both sides by 3. X equals 8 over 3. And then you should always CYA. Check your answer. Because before you hit enter on a homework or a test and you're solving for a variable, you should know if it's right or wrong before you ever hit enter. There should be no reason you should ever make anything less than 100 on any assignment or test. How do you check your answer? Yeah, take this, plug it into the original equation. So our original equation was this. That's the original equation. Anywhere I see an x, put an 8 over 3 in there. So anywhere I see an x, I put an 8 over 3. Now, on the left side, 3 times 8 over 3. I can cancel those. So it's 8x minus, or 5 minus 8. On this other side here, I can distribute that -3 inside there. So negative times positive is negative 3 times 8 over 3. Negative times positive is negative. As long as there's a rule that says you can do it anytime you want to. That's distributivity. I can do it anytime I want to. I don't have to wait till the very end. I can do it in the middle of it. So these threes cancel. So I have 2, 5 minus 8 equals 8 minus 8 minus 3 times 2. Order of operations, I got to do inside the parentheses. 5 minus 8 is what? It's going to be positive or negative? Negative. 8 minus 5 is 3. 8 minus 8 cancels out. That becomes 0. So I have -3 times 2. So my answer is correct. So you should never be surprised that your answer is wrong. The only time you'll be surprised is if you're too lazy to check your answer. And you deserve it in that case. So far, so good? It's the same processes. Let's look at another example. -24x plus 7 equals 17 minus 24x. Okay, so what's my first step? Do I have any parentheses? No. So there's no special operations. So I have x's on both sides. Which x do I move? It doesn't matter which one. So how do I move this one? Plus 24x plus 24x. And that cancels. So what does this tell us? Does 7 equal 17? What does that tell us? That means there's no solution. If all the x's disappear and whatever you're left with is not equal, no solutions. There's nothing you can put in there that'll make it work. So if all the x's disappear and you're left with numbers and they don't equal, no solution. Let's find out. It's like an infomercial. I set you up perfectly. 3 minus 1 over 3x equals -1 over 3x plus 3. So we have fractions and equal sign. What do we do here? I want you to get used to a pattern. Don't just memorize one thing for one type of, do it for general. So since these are fractions and the equal sign, we do our 5 steps. What's the LCD? 3. What do we do with the LCD? Multiply it to each term. How many terms do we have in our equation? 4. Here's one term. Here's one term. Here's one term. So I multiply 3 to each of these terms. Each of those terms get a 3 in front of it. Next step, reduce. So the 3's and 3's cancel, the 3 and 3 cancels. We're left with next step. Multiply to get rid of the parentheses. 3 times 3 is 9 minus x plus 9 and solve. If we add x to both sides, we're left with, does 9 equal 9? So we have an infinite number of solutions. Every answer, every number you put in there will be an answer. So if it equals at the end, that means no matter what you put in there, you can't go wrong. That's what it means. All right. Now is the part of the class you'll hate the most. Word problems. Example 5. There are about 232,000 words in the Japanese language. This is 19% more than the number of words in the Russian language. So, how many words are there in the Russian language? Question mark. So how do we figure this out? What x? We have to come up with an equation first. But 19% more than the words in the Russian language. So the Japanese language has 19% more words than the Russian language. Now we have to put it into an equation. How do we put this into an equation? No, it, because it's not over time. This is it. Yes. So yeah, well, yes. Or X and Y if you want, but J and R is much easier. So the number of Japanese language is 19 more than what the Russians have. Not yet, but we haven't set up an equation yet. 19% more words in the Russian language. So first let's do the equation variables first. Don't put numbers in there. But this thing says it's more than, so we first start off with the number of words in the Russian language. So whatever number the Russians have, there's 19% more. So we have to add 19% more of the words in the Russians, whatever the Russians have. So the Russians start off with their words. We have to add 19% more of those words into the language. Now we put it into numbers. What is J? 232,000. Russian, we don't know just yet, but it's R. What is 19% into decimals? 0.19. So we have 232,000. R, which is 1R, plus 0.19 makes it 1.19 R. What does R represent? The Russian languages. So to get R by itself, what do we do? Divide by 1.19. Be some ugly number. So we have 232,000 divided by 1.19 equals 194,957.9, which makes it approximately 194,958 words in the Russian language. The reason this is the most difficult part of math for students is because all the years you spent going to school, first off, you didn't pay attention to most of your teachers. You're too busy doing other stuff. And two, you were never taught to read for specific information. Every time you read something, you were asked, what is it about? General content. Yes. Because the Russian language plus 19% of the Russian language. So what is 19%? That's 0.19. 19% is 19 divided by 100. That's what percent symbol means. So we have this R plus 0.19 R, which is 1 plus 1.9 is that. Yes. And then, well, yeah, see, that's the part. Then and then and then and then. The more and thens you have, the more complex it becomes. So no, I'm going to show you the most simplest way to do it. Yeah, there are infinite ways you can do it, but this is the most direct and the most sequentially logical method to do it. Yes, there's a whole bunch of and then ways you can do it, but I'm going to avoid those. Question.
Could you just multiply the whole number? 232,000 by 3.81.
You could, but how'd you get that? Again, you had to first find this number. And then, yes, you could have done that, which is the same thing as dividing it by 1.19. Again, there's many ways you can do it. And I don't want to go to those because don't learn one specific way. Learn a general way to do all your questions. Yes, you could have done that, but that's just going to be confusing for everybody else. You can do whatever you want to, but in everybody else, this is how you set up an equation. You start off with what you have, you either add or subtract. If it's an increase, then you add them. If it's a decrease, you subtract it. And then whatever you have here, then you divide by the overall answer. That's the way you work it out. All right, next question. Convenience stores. In 2014, there were 151,282 convenience stores in the US. The total number of stores in Texas and California was 26,379. There were 4,003 more stores in Texas than California. Find the number of stores in Texas and California. Again, as I said earlier, you were never taught to read for specific information, just general content. The first sentence up here, what is that good for us? Tell us. Is it worth anything for us? No. It's superfluous information that we don't need anything about it. We only need what's in Texas and California. Now, since we have two pieces of information, Texas and California, we need two equations. The number of variables tells you how many equations you need. You have to have one that relates to two variables, and one is the overall question itself. Now, this first one, there were a total of 26,379 stores in Texas and California. How do I put that into a formula? Texas plus California equals 26,379. So there's the general formula. Now I got to find a relationship between Texas and California. That's what the next sentence comes in. There were 4,003 more stores in Texas than California. How do I write that down in the equation? No. What it says is in order for Texas and California to be equal, I have to add 4,003 to California. Because Texas has more stores already. So in order for them to be equal, the number of stores, I have to add 4,003 to California. Again, it's how you read and interpret what's given to you. That's what makes this difficult. Most students would do Texas plus 4,003 equals California. That's wrong. Because that means California has more stores. Now, once we have this, we have the overall formula, we have how the variables are related. What do we do now? Now we substitute and solve. We have to put these two equations together. In place of t, what do I put? California plus 4,003 plus California equals 26,379. I can only solve an equation if it has one variable. You can only solve it if it has one. If you have two variables, you can't do anything with it. You have to find the relationship. Now, since I put these two together, it's called substitution. I took this equation here. Anywhere I see a t, I put it in this place. You notice I have one equation and only one variable. I can solve for c. C plus c is 2c. Next step, subtract 4,003. So 2c equals 9 minus 3 is 6, 7, 3, 2, 2. Now I divide by 2. So the number of stores in California is 1, 1, 1, carry the 1, 8, carry the 1, 8. There are 11,188 stores in California. Now, to find the equation for Texas, well, we have that equation right there. All we need is the value for California. We have that. So Texas is equal to California plus 4,003, which is 11,188 plus 4,003 gives me 15,191. I take whatever I found in California, add 4,003 to it. That gives me the number of stores in Texas. How do I check my answer? Texas plus California has to equal 26,378. So Texas plus California. It's 15,191 plus 11,188. 8 plus 1 is 9. 9 plus 17. 3, 6, 2. And that's what number I needed. Fortunately for you all, it's only one section we have to hurdle through these word problems. And we're not done yet because we're almost out of time. We have a couple of more because we haven't talked about business problems yet or interest, profit, loss statements. We'll do that tomorrow. And we'll finish up the chapter tomorrow. And that's my goal is I want to finish a chapter a week. We have to, so we can finish the course. Any questions? Well, I'm gonna send it to y'all. I'll send it to you all via reminder. It's faster that way. The notes, again, I've scanned the notes a dozen times, but they never come through. So I have to scan them at my house, which takes a little bit longer.